It began with the faintest of signals, just a small anomaly in the data. Something cold, fast, and eerily quiet was moving through our solar system in a manner that defied everything we understood about celestial motion. Observatories from Hawaii to South Africa were the first to detect it. NASA soon confirmed the finding, an unidentified object behaving in ways that broke conventional expectations. It was not bound by the familiar gravitational laws, and even more disturbing, it had originated from beyond our solar system. Initially, it appeared to be just another asteroid, but within hours, peculiar patterns started to emerge. Its velocity was too high, its path too deliberate, and its reflectivity too intense for something thought to be a natural rock. As scientists mapped its trajectory, what they discovered was chilling. It was heading directly toward the inner solar system. For years, we've assumed space to be vast, quiet, and indifferent. But this visitor, racing silently through our cosmic neighborhood, began to challenge that assumption. The James Webb Space Telescope soon shifted its focus to this object, and what it began to uncover hinted at possibilities we may not be prepared to accept. A haunting question began to surface. What if this wasn't just a passing object, but something observing us? Between June 25th and June 29th, the object, now designated 3I, later referred to as Atlas, was detected by the Asteroid Terrestrial Impact Last Alert System Atlas, a rapid scan system designed to locate potentially hazardous objects before they surprise us. But what Atlas found wasn't ordinary. This object was moving at over 152,000 miles per hour. Its orbit didn't match the typical paths of comets or inner solar system wanderers. When researchers used simulations to trace its path backward, the results were startling. It didn't come from the Oort cloud or the orbit of any known planet. Its origin pointed to deep interstellar space, possibly the galactic core. This was not a leftover fragment from the formation of our solar system. It was something that had been traveling the dark reaches of space for tens of thousands of years undetected until now. And yet the most unnerving question wasn't about its point of origin, it was, why now? Before 2017, humanity had never documented an object from outside our solar system. Since then, we've encountered three. Each has been more unusual than the last. Following the confirmation of Atlas, researchers across the globe rushed to obtain observation time with the James Webb Space Telescope, humanity's most advanced tool for studying the universe. Built to observe the earliest galaxies and peer deep into time, Webb now turned its lens on something far closer and potentially more disturbing. The object's brightness didn't align with its size. Based on its light reflection, it should have been massive. Yet measurements suggested it was relatively small. That discrepancy meant its surface wasn't acting like ice or stone. It was behaving more like polished metal, cold, reflective, and perhaps even hollow. Harvard astrophysicist Avi Loeb, who had previously theorized that the 2017 interstellar object Oumuamua might be artificial, once again raised a compelling point. He encouraged fellow scientists to search for signs of non-gravitational acceleration, small deviations in its motion that couldn't be explained by gravity alone. If such deviations were found, they might suggest that this object wasn't just moving, it was steering, and if it was steering, then it wasn't a drifting rock. It was making choices. To grasp the significance of this, we must revisit the two interstellar objects that preceded it. The first, Oumuamua, was discovered in 2017. It had an elongated shape, no comet tail, and displayed an unexplained acceleration after passing the Sun without any signs of gas emission or propulsion. Then in 2019 came Borisov. It was a comet, clearly so, but it moved faster and burned brighter than any seen before. Each encounter left scientists with more questions than answers. Atlas, however, brought traits from both predecessors: the inexplicable brightness of Oumuamua and the high-velocity path of Borisov. It didn't fit into any known category of comet or asteroid. Now, researchers are beginning to entertain a more unsettling theory: these objects may not be random at all. They could be part of a sequence, a deliberate pattern disguised as chance. For centuries, our skies remained quiet. Suddenly, they're not the only thing that's changed. Is us. Hidden behind technical papers and orbital models is a question that institutions are hesitant to ask aloud. What if the object isn't natural? When explanations fall short, when light is too intense, motion too precise, and deviations unaccounted for, one possibility remains, one too unsettling for mainstream discussion: artificiality. Not in the cinematic sense of flying saucers or extraterrestrial beings, but as probes or autonomous devices sent long ago from distant, ancient civilizations. Loeb proposed that perhaps we'd already missed the signal from Oumuamua, and that Atlas might be our second opportunity. Its unusual surface, incredible speed, and suspicious timing suggest intent, or at least design. James Webb's instruments are now meticulously tracking its heat signature, rotation, and course. But the real question isn't what it is, it's who might have sent it. In a universe that's 13.8 billion years old, the most haunting possibility isn't that we're alone, it's that we've been under quiet observation for longer than we ever imagined, and only now have the tools to notice. As more days passed, data from Webb and ground-based observatories revealed something even more disturbing. The object was accelerating slightly, just enough to stray from expected paths. But this wasn't due to typical outgassing seen in comets. There was no tail, no particles, no emissions. Yet its trajectory continued to drift with uncanny accuracy. Infrared sensors picked up a stable thermal pattern, not the chaotic heat of natural bodies, but a consistent, engineered emission. This behavior was eerily similar to what scientists observed with Oumuamua, which had also exhibited unexplained acceleration. But this time, it wasn't dismissed, it was verified, and it brought with it a silent fear. Because acceleration without force implies something else: control. For the first time, internal discussions among scientists began to reflect this unease. What if we weren't just observing this object, but being observed ourselves? At NASA's Goddard Space Flight Center, a full spectral analysis was conducted. Researchers expected to find silicates, metals, and other natural elements. But the results didn't match anything cataloged. Certain absorption patterns suggested the presence of advanced carbon-based materials, ones more likely to be engineered. Then naturally formed, the object's surface was highly reflective, and its rotation showed signs of symmetry, rare in cosmic debris. One side absorbed more heat than the other, hinting at possible design. Electromagnetic fluctuations suggested internal complexity, perhaps even cavities or structures. It no longer resembled a rock, and if it wasn't a rock, what was it? The question began circulating far beyond scientific circles through space agencies, international observatories, and classified government sectors. If this wasn't a product of nature, then it was built. And that implication triggered an unprecedented shift in response. Initially, space agencies like NASA, ESA, and ISRO shared data openly. But then unexpectedly, updates ceased. Mission pages stopped updating, requests for raw data from Webb were denied under review. Freedom of information requests returned with heavily redacted responses. Researchers were removed from teams, reassignments were made, and access to live telescope feeds was quietly restricted. What began as a scientific curiosity had become something else, an issue of control. The reason? Something had likely been discovered that didn't just stretch scientific understanding, but challenged political and existential frameworks as well. Because when a discovery crosses a certain threshold, threatening foundational beliefs about physics, security, or our place in the universe, it's no longer just science, it becomes governance. And silence, as it turns out, is just another way to maintain that control. The object's journey through our solar system is ongoing, but a shift has occurred in how it's perceived. It's no longer just an anomaly, it's a reckoning, an inflection point in our understanding of reality. If artificial, it was created by a civilization unimaginably old and advanced, capable of building something to drift through interstellar space for eons without decay. A civilization that might never need to speak, because presence alone is message enough. And if not artificial, then we've encountered a natural phenomenon so rare and so intricate that it resembles intelligent design to a frightening degree. Either possibility forces a sobering conclusion: our grasp of the universe is still fundamentally incomplete. And now, the James Webb Space Telescope has reflected that ignorance back at us. We are no longer alone in our wondering. Perhaps the void has been watching us all along, and now, finally, we've become visible. As curiosity turned to concern, an even more unsettling theory began to take shape. Not in published journals or televised interviews, but in encrypted conversations among scientists. What if this object wasn't found by coincidence? What if its arrival was carefully timed, its path, our technological readiness, and the orientation of the Webb telescope all aligning in a predetermined sequence? What if it was a probe designed to be seen, a test deployed to measure our response? In that scenario, we aren't discovering it. We're being assessed. Consider the silence of the cosmos: no radio signals, no